At this unpacking one, and this is just looking a little more detail at the stuff I mentioned in the previous video about the strings of executable files. So, it's in Opera, that's why I'm having trouble finding my virtual machine. There we are. So here's my cloud machine running Windows. Alright, and I'm done with Process Explorer for now, and I'm done with this thing for now. So I'll press enter. I said I'll press enter. Thank you. All right. And I've got the instructions open here too, which is a good thing, so I can copy and paste from here. All right. So there's these malware samples that come from the book Practical Malware Analysis, and I still use a few of them. And so there should be on the desktop of these machines. Yep, Practical Malware Analysis. The samples are in there. This is one of the many reasons why you have to have the antivirus turned off, because it'll freak out about these. They're not real malware, but about half of them will trigger Windows Defender and it will delete them. So bin text is a nice graphical version of strings, which is very handy. So looking at the Lab 0102, it's browse, go to the desktop, and then into that Practical Malware Analysis Labs, and another folder, Binary Collection, Chapter 1, and then lab0102.exe. There's the file. And when you examine these strings, now I think there's no way to make this bigger, unfortunately. I might be able to lower the resolution of my host bit. Let me see if I can do that just for a moment. Right-click, personalize. Actually, display settings might even be better. Let's do right-click, display settings. See if I can make it a lower resolution. Scale and layout, that would... Display resolution, there we are. Let's try going down to like 1024 by 768. See if that makes it... That might make it easier to see this screen. Yeah, I'm not sure it actually helped any. Anyway, let me try one more thing, because I know these videos get kind of low resolution. I'm going to find bin text and make a shortcut and see if I can run it in compatibility mode. That might do it. Right click. All right, it doesn't have the option I want there. If I right click and drag, there we are. Now it should give me create shortcut here, but it's not. All right, open file location. Now it will let me do that. Right click. This is what I'm looking for. Send to desktop. Create shortcut. Okay. And now, with a shortcut, I should be allowed to use Windows compatibility settings and make this run in like 640 by 480 screen resolution. There, let's see if this works. There we are. Now it'll be bigger. Neat. Okay, so I open the Lab 0102 and go. And so you always see this thing, this program cannot be run in DOS mode. Here's some interesting looking stuff, mal service and some funny name. And here's part of a URL, but it's broken up. So what's happened here is the strings have been sort of garbled, so it's not obvious. I don't see the whole URL, and I only see a few system libraries here, like kernel 32 and advanced API 32. And these are Microsoft API calls with this words that are rammed together with each word capitalized. And one thing about Windows API calls is they often end with an A or a W or an EX. The A means they use ASCII, the W means they use wide characters, Microsoft 16-bit Unicode characters, and the EX means it's an extended version of an earlier API call from an earlier version of Windows. You often see those at the end of Windows API calls. Here's some more copies of sort of garbled strings. Here's some more Microsoft API calls, more library names, and some more API calls, and that's it. And what you're seeing here is a very small, short list of strings with very little information in it, and that's because this is a packed file, and all you're seeing here is really the unpacker. So to unpack it, you got to use your command line. And one simple way to do it in modern versions of Windows is to go into the folder and then open the command line right from the Explorer, which is pretty nice. Right up here, File, Open New PowerShell here. And then I'm already in the right directory. And as usual, let me make the font bigger for the video and the people viewing. Just make it bigger. That'll probably do. All right, so if I do a dir, I see the various files here, and here's the one I want. And that file is very small because it's packed. And we can unpack it with UPX. But let me, before I do that, let me demonstrate some of these other utilities that I skipped. Like PEID is a program that just looks for certain signatures in the file to tell what language it was written in and other basic facts about it. And actually, let me do the same thing I did before and make a shortcut to make that bigger. So if I open File Location and then send it to the desktop, and then make the shortcut run in 640 by 480 mode, it will be easier for people to see. Compatibility 640 by 480. There we go. See how that looks. There we go, much better. So if I open that file, which was Desktop, Practical Malware Analysis Labs, Chapter 1, 10102.exe. There. Now you see it doesn't know what language this was written in. This is unusual. Normally you'll see something found here. For comparison, let's launch another instance of this and look at the program we just wrote. We just wrote a program called 99.exe. That's funny. It didn't open in compatibility mode when you opened a second instance of it. I'm getting ripped off, aren't I? Let's see. Looks like a defect in Microsoft's glorious compatibility thing. Anyway, if I do, oh, now it's done it. All right, so that program was at C99. Here it is, the program we just made. And that also told me nothing found. I expected it would be able to see that I wrote that in Microsoft Visual C++. That's a little rude, but it is a Windows 32 console program, and if you look at the sections, it's the usual sections, .text, .rdata, .data, and .relocation. So that's the way a normal Windows executable looks. But if you look at this simulated malware sample, Labo 102, which I gotta navigate to again, Desktop, Labo 102. It doesn't know the name of it, and if you look at the sections, they're UPX0, UPX1, and UPX2. This is very strange. Every file has to at least have a .text section in order to run. That's where the executable code lives. So this is the result of the UPX packer. The UPX packer compresses files on the disk, and then it loads them manually into memory. It does not use the standard Windows loader that would just copy the disk file directly into memory. It unzips them and sends them up to memory. This means the file is smaller on the disk, and the strings are garbled. So it's popular among malware authors to use a packer. And that's what okay. Now let's take a look at PEView and see what that file looks like directly. PEView. All right. And now I open the malware sample on my desktop, which is this, and Chapter 1 and Labo 102. All right. And this one, I think, has a font adjustment I can use. View font to make it bigger. I can just choose a bigger one here. All right. This is a very good utility, a special viewer just to see what's inside Windows executable files. And you've got a directory on the left of the major parts of it, and on the right, you've got a raw binary view and a hex viewer of just what's in there. So this is what files look like in raw hexadecimal. They always start with MZ, executable files, and then they always have this message, this program cannot be run in MS-DOS mode, which is strangely garbled here. All right. And then down here, I'm going to see the name of sections like .rdata and .data. And then a whole lot of zeros. Here's a couple library calls. Remember, this is a packed file. All right. And let's see what else is worth mentioning here. Here are the segments. You'll see them here. And here's the section headers. Now, I should see the section names here. Somehow, I'm not seeing what I should normally see in PE View here. Maybe my font is too big. Let me try changing my font down again. View font. Let's make it smaller again. That's actually a little disturbing. Just a moment. I'm going to get this resolution back where it should be and see something is, it's not showing me the usual stuff there, and I suspect it has to do with my display resolution being a bit smaller than it should be. All right, let's see if this helps. Now if I run PE View, all right. Let's look at Labo 101, which is not compressed. This is what you see in a normal file, text, rdata, data, and this program cannot be run in DOS mode. That's the normal stuff you should see. Now let's look at the packed file, Labo 102, and here we are. Now we see them, UPX0, UPX1, UPX2, and here's those section names, and here's this program cannot be run in DOS mode because it has to have the usual headers just to run the unpacker. So this is called the MS-DOS stub program, this stuff. It is a useless appendix left over from the days of MS-DOS that's at the start of every Windows file. The real header that matters is the NT header that starts up here. It starts with this PE mark, which is the portable executable mark, and then it has information about how the file is made, and the image optional header tells you things like the version of the linker that was used to make the file and the image base address, which is almost always 400,000 for Windows executables. That's where it thinks it's going to load in memory to run. It's a virtual address. It will really load at another location, but it will think it's at 400,000. And then you have the data sections. Down here, these are the headers that tell it how big it are. Notice that the size of this section is 0, which is very unusual, along with the unusual name. And if you look at what's in that section, it's nothing. There's no data there at all. It has 0 size. UPX1 has got random bytes. This is the compressed data for the file. This is going to be unzipped and loaded into memory into the real sections. And UPX2 has the import directory, which shows all the Windows libraries that are used, and then the address table, which shows the specific system calls it's going to make. And as I mentioned, this is a very short list. Every Windows executable, even a simple one, would have more than this, but it's going to do a few things. It's going to open an internet URL, create a service, and do a couple things having to do with allocating memory segments. This is the unpacker. I don't know why it's calling the internet, and I don't think it's really going to do that, but it has to do this. It has to allocate regions of memory and unzip the data and pack the file, unpack it to load it into memory. So that's what I want. We can also look at it in CFF Explorer, which does pretty much the same thing. And you might wonder why you use several tools that do almost the same thing. And you really get used to this in malware analysis because the authors try to confuse your tools and they modify and mangle the files. So often the tools fail. So one of the things to get used to in the world of malware analysis is your tools often give you wrong answers or fail, and it can be a real long job to figure out why. And the practical thing to do is just try another tool. And be aware, the bad guys are fighting against you. So you need to have a library of tools you use. So this just gives you another view into the file. And down here you can see it in a hex editor, the raw hex version. And we can see the import directory here, which again shows the libraries that are in use, kernel 32, advanced API, and how many functions are used in each library. 6 in the kernel and 1 in each of the others. And that's the unpacker. So now we'll unpack it, which is what I was about to do earlier. So here we are. There's the file that's packed. On this machine is already installed the free tool UPX. And if you run it, it will have a help message, which is pretty simple. The only thing we need to do here is decompress a file. So you do UPX, decompress, and we need to tell it where to put the result, which is -O. So it's UPX, there, -O. I can probably type this one, it's pretty simple. -O, this is lab 01, 02 unpacked. .exe, and then put in lab 01, 02.exe. That should do it. And it gave me some kind of already packed. Oh, I forgot to tell it to unpack. It was trying to pack again. Okay, I got to use -D to tell it I'm decompressing. All right. So keep going. The machine is strangely not responding. All right, just give it Control-C and up arrow. Let's see if it'll do it now. Here we go. There's always little defects. Okay, decompress, putting the output, there it goes, decompressing. So it was 3,000 bytes, it unzips it, now it's 16,000 bytes. And if I do a directory, I'll see here's the unpacked file that is bigger. And now that it's bigger, I should be able to see the strings. So let's take a look at it, for example, at PE view. Now it should look more like a normal file, the unpacked one. See, now these have the normal names, .text, .rdata, and .data. And if I go to the text section, this has got executable machine language instructions, which look like random bytes. Here's the data. Here's the import address table. Now I have many more functions. See, I've got a lot of functions in the kernel, a lot of functions in the advanced API, a bunch more functions called in this thing called MSVCRT. You know, that's a program that's doing something now. And there's a data section with some strings in it, including my indicator of compromise. Here is the Command and Control Center URL, http://www.malwareanalysisbook.com, because this is the uncompressed file. And the strings with important indicators of compromise are just right there to see, which is very nice. And of course, that's why the author compressed it to make that more difficult. And if you look at it with CFF Explorer, you will see that it has more calls in the library. This should be showing a higher number than 6. I think that might be the wrong image. Yep, that's the compressed image. I got to replace that image. It shows a higher number. And anyway, then you can examine the strings, and you will see a lot more strings in the unpacked file if you use bin text. So if I run bin text here and look at the unpacked file, I should see a lot more strings, including the important strings. So I'll use the page down key. There we are. Oh, look, here we are, the whole URL of the Command and Control Center. Here's that string, this program cannot open in DOS mode. And I think there's, I thought there might be an IP address in this one or something, not this one. Anyway, you see another copy of the entire URL for the Command and Control Center, and so on. So, that's good stuff, and there's a couple of challenges here. And I'll stop this one.